Hi, this video is all about the answers to the Geological Map Application questions for the Clitheroe map of 2011. This image shows us one of the two reservoirs on the map that you're asked questions about on the side of Pendle Hill in Lancashire. You can see it's an earthfill reservoir because it's built on fairly weak rock. Let's have a look at what type of rock we're talking about. This shows the part of the map that this question is related to, asking for geological reasons for the location of these reservoirs. Now, the rock here is Bowland Shale Group. Now, the Bowland Shales are a big, thick band of shale that underlies a lot of the northwest of England. It's a group, for example, that's been explored for its shale gas potential for fracking. But in this particular case, we need to consider its permeability. Not only that, you can see from the symbol here the fact that we have this sort of upturned triangle with a sort of line running through it, shown as a symbol above the abbreviation for the Bowland Shales, that this area is overlain by boulder clay, or till, perhaps it would be a more modern term for it. Now, as a result of this, these two rocks are going to be impermeable. Till is impermeable, and shales have a very low permeability. The consequence of that will be less leakage or less chance of leakage from these two reservoirs. If we look at the topography of this, they're both in the bottom of valleys. Clearly there's some high ground around, so you'll have a lot of water flowing down into this valley that can be trapped in these two reservoirs. We also get the sense that these rocks are quite stable. There's very little evidence of faulting, for example, in this area. The second question then moves on to look at the landslips, the mass movements that have been mapped on the side of Pendle Hill. These areas with this vertical lines as a symbol are areas where a mass movement has actually been mapped in. The question broke down the components of this for you to consider. And it'd be well worth in your answer following that same structure. Use the help that the examiner's giving you to organise your ideas. So let's follow it through in the same way. So if we think about the rock type and how the rock types contributed to these mass movements, and this is going to be a high chance of contributing. We've got Pendle grit, which could well be permeable, overlying an impermeable shale. Now that means you're going to have water building up at the bedding plane between the two. Clearly that can cause some lubrication issues. If you look at the dip and the dip angle, now in this particular case, it's really not contributing at all. If you look, the beds are actually dipping into the slope. They're all dipping to the west here on an east-facing slope. Not only that, they're also very shallow dips. They're going to be well below any sort of basic friction angle. So the dip really isn't contributing in this particular case. The steepness of the the slope, though, in terms of the surface topography, this is contributing. You can see that the contours are really closely packed together. We've got a very steep slope here, possibly the result of glaciation. We've seen evidence already of glacial deposits in this area, but this does allow material on the slope to flow more easily and perhaps to be less stable on this oversteepened slope. The local groundwater conditions, then, this is clearly having an effect. There are springs and streams associated with each of these landslips. The shale, when it's wet, can lose its cohesive strength, and this water, particularly if it's under pressure in groundwater, can act as a lubricant. Faulting. The more northerly of these two landslips, there's no evidence of faulting anywhere close. The southern one, maybe. There's evidence of a very small fault, but it's probably not very significant. However, of course, these are only the faults that have been mapped, only the faults that geologists have found evidence for in rocks exposed at the surface. There may be other ones, perhaps even ones underneath those landslips, that may have had an effect on triggering such a mass movement. It's hard to tell. But you know, can you come up with that judgment? Can you make that evaluation for this question? So, as we see the sunset over Pendle Hill, this question shows the importance of following any structure that's given by the examiners. Okay, if they give you a list of things to consider, deal with each of them in turn. It will make it far easier for you to pick up marks rather than just trying to talk on at some length about these different aspects and run the risk of missing things, run the risk as well of just sort of waffling on rather than getting to the point. If you've got any questions, ask me in class. I'll see you next time.